Alright, page 2 of the sample test. So we have a piecewise defined function, and we're supposed to graph it. So this looks like excuse me, y equals 3 minus x, but only for x less than -1. So if I draw my axes on here, and I put some units on here, and on here, so less than -1 x's. So I got to draw it over here. So if I put in -1, which I'm not supposed to, but I can, I get 3 minus a -1, which is 4. That's where it'll start. And then if I put in -2, 3 minus a -2 is 5. And we can get that one, and so we can see it's got a -1 slope headed to that spot. I could put more in there, but it keeps going that way because it works to negative infinity. Okay, then from -1 to 4, it's x plus 2. So if I put in -1 where it starts, -1 plus 2 excuse me, is 1. And if I put in, let's say 4, this is a straight line, so if I put in 4, I get 6. 1, 2, 3, 4, I get 1, 2, 3, 4, 5, 6. And this has a slope of +1. And it's supposed to go through 2, which it did. And I get to keep both ends, and that's all the further it goes. Stops at 4. 4 in the x. So there's the graph. It looks like it has one intercept, a y-intercept of, and the interceptor points 0, 2. If I put in -5, I would put it in that first equation. So 3 minus a -5 is 8. And if I put in 2, 2 gives me 4. Or I could put 2 into the one where 2 fits in this domain, and that's this one, which is 2 plus 2, 4. Number 6. G minus k of x. So that's g, x plus 1, minus, and I'm going to put a parenthesis just so I make sure I distribute my minus, k, which is x plus 5. So I have x minus x, which is gone, and 1 minus 5 is -4. So that turns out to be a constant function. Don't know why I got a cough here all of a sudden. Okay. B. This is times. This is a solid dot, so I'm not doing f of g, I'm doing f times g. So I got to put -4 into f and g and multiply my answers. So 4 into f, that's 4 squared minus 2 times 4. And all of that times, and put that's -4 I'm supposed to put in there. And then I got to put -4 into g, which would be -4 plus 1. So I have -4 quantity squared, which is 16, and -2 times the -4 is plus 8. And I got to take that times -4 plus 1 is -3. So that's 24 times the -3, which is -72. C. I'm supposed to put h of x into f of x. H of x is the square root of square root of 3x minus 2, and I'm supposed to put that into f, which I was got to put it for both x's, so the first x is squared, minus 2 times the x, which we're putting h of x in for. So that squared is 3x minus 2, really just the absolute value of that, but I'm going to leave it just that way, minus 2 times the square root of 3x minus 2. Find the domain of k of h of x. So I got to put h of x in for the x in this, so it's going to be the square root of 3x minus 2, in for the x and h of x in k of x, which means that that x turns to the square root of 3x, and then we got plus 5. 3x minus 2 plus 5. That's k of h of x. Now, the only thing that might run into a problem here is I have to be able to put the numbers into here, so this find the domain, so the 3x minus 2 would have to be greater than or equal to 0 to be able to take the square root of it. So if I add 2 to both sides, I get 3x equals greater than or equal to 2, divide by 3, x is greater than or equal to 2/3, so that means the domain would be from 2, including 2/3 to infinity. H inverse. So h of x, I'll write that down, h of x is the square root of 3x minus 2, so that's the y, that's the x, swap them to find the inverse, so x equals the square root of 3y minus 2. To solve for y, I have the square root on everything, so square it to get rid of it. Add 2 to both sides. And divide everything by 3. And h inverse of x, or y, equals x squared plus 2 divided by 3. Now it says find the domain and range of h inverse of x. Well, it looks like I can use anything in here, but we need to refer back to h. Now h, we couldn't use anything but 2/3 to infinity, and that was because of this part right here. So that's the domain. That was the domain of this also. So 2/3 to infinity, and I would get out of it, let's just look at here, the domain would be 2/3 to infinity, and what I get out of here, 2/3 makes this 0, and go to infinity makes things positive. So I get from the domain, I get a range out of this, and you can also graph this, and you'll see that this has a range from 0 to infinity. So for h inverse, it's just the opposite. It's going to be, the domain is going to be from 0 to infinity, and the range is going to be 2/3 to infinity. They swap. Okay?